Hello and welcome to the course of Computer Network. This lecture is in the continuation of the last lecture in which we started discussing about transport layer. And today we are going to study one of the service provided by transport layer. And as we all know that transport layer provides us process-to-process delivery, which is achieved by two most dominating protocols present at transport layer. So today we are going to discuss one of them. And First, we discuss about UDP, User Datagram Protocol, which is used for uh, providing the process to process delivery of data in a very fast way. Basically, UDP is a protocol used by those applications which needs fast communication from one end to the other. So here we see UDP user datagram protocol, which comes under RFC 768, and this particular slide gives you a brief introduction about user datagram protocol, which tells us about that this particular protocol is used for fast communication, as it's a connectionless and unreliable protocol, but it gives you best effort delivery, and it is not responsible for any loss, as it says over here. And it is also not responsible for the ordered delivery of the data, because it's a connectionless protocol, and each UDP segment handled independently of others. So as it's a connectionless, no handshaking is required between client and server, and these are the applications which uses this particular protocol as a transportation service. As you can see, we have studied many protocol in application layer, but out of those, one of protocol which we studied at application layer was DNS, which uses UDP as its transportation service. So we can take example of DNS, and we can go ahead. As we all know that DNS is a protocol which is used for getting the IP address from DNS server. So DNS generates a query at the client side at application layer, and when that query comes down to the transport layer, now the responsibility of transport layer is to provide you the process to process delivery. That means responsibility of transport layer is to send that particular DNS query from DNS client to the DNS server process which is running at the destined system. So when that DNS query comes down to the transport layer, here the responsibility of transport layer starts. And as we all know, DNS is a application which uses UDP as a transportation service. So UDP, how UDP provides the process to process delivery, that we will see shortly. But before that, let's complete this particular slide. As we see, the last thing over here is UDP itself doesn't provide you the reliability, but uh, you can add reliability at application layer. So it is completely up to the application. If that particular application wants reliability, then that particular application has to uh, provide reliability at its level, because UDP doesn't provide you the reliability. As you can see in the next slide, uh, this is the format of a UDP header, and you will be very strange that it's a very small header which you can see over here. The bottom portion is the payload which has come from the application layer, or you can consider it as a DNS query, and the upper part has only 4 fields. So the first field is source port number, the second field is destination port number, the third field is length, and the fourth field is checksum. So we'll go through them one by one. So first of all, we'll start with the source port number. As we all already discussed, port numbers are used for identifying the particular process running inside the machine, which is a 16-bit number. So in this particular case, as our machine, client-side machine, generates a DNS query, and that DNS query is combined with the UDP header. This part is the UDP header, and this is the DNS query. So this source port number would be the port number of client-side process, and that process name is DNS, domain name system application, which is running at the application layer. So our client machine's operating system will generate a random 16-bit port number, and which will be assigned to this particular process. This particular process means which is assigned to DNS client, which has generated that particular query, and that number we will put in this particular field. So source port number is the port number of that process which is generating the DNS query at the client side system. Now again, next field is destination port number, and now you must be uh, feeling strange that how client-side machine will get to know about the destination port number, because this machine is very far from the server side, DNS server side. So how this client-side machine will get to know about the DNS process? So as we have already discussed in the last lecture that port numbers are divided into three categories. The first category of port number is well-known category, well-known port numbers starting from 0 to 1023. So this particular first category belongs to well-known port numbers, and these port numbers are given to well-known servers only. Like STTP is given port number 80, SMTP, Simple Mail Transfer Protocol, is given port number 25. In the same way, FTP is given 20 and 21, and in case of DNS, that port number is 53. So at the source port number, you will put the client side process port number generated by the operating system for your process, and at the destination port number field you will put 53 because that port number is well known for DNS server. So here are the two port numbers which you have to put in these two fields for process to process delivery. This source port number is used for identifying process running at the client side machine, and destination port number is used for identifying DNS server process running at the destined or destination machine. Now the third field is length, and as you can see again, length field is also of 16 bits long, and if all the 16 bits are 1, then the maximum number which you will get is 65535. So from 0 to 65535. So the maximum length which you can have in this particular field is 65535, and this length is the combination of this particular data which has come from the application layer and the fixed size of this particular header, which is got 8 bytes only. 2 bytes, 2 bytes, 2 bytes, 2 bytes. 2 bytes are used for source port number, 2 bytes are used for destination port number, 2 bytes are used for length field, which is the complete length of this particular segment, UDP segment, which is a combination of this particular payload and the header part, fixed length header part, and the checksum field, again 2 bytes. So length field will provide you the size of this particular segment, and if you want to know the size of this particular payload, you need to subtract 8 bytes from the number which is given in this particular field. So this length field gives you the complete length of the segment, which is a combination of payload and this header, fixed header, 8 bytes header. Now we'll come to the last field of UDP segment, checksum, which is used for detecting bit errors at the destination side in this particular UDP segment. So it will it will check the complete segment at the destination. If you fill these 16 checksum bits in a proper way over here, so at the destination you can check whether your UDP segment has arrived properly or not. So we will discuss this particular field, checksum field, in our next slide. Before that, we'll complete this slide. As we see, it says UDP provides the fast communication. Why UDP is able to provide you fast communication? Because there is no connection establishment in UDP. A client and a server, they do not have to create a connection before sending the data. And as you can see, one of the biggest thing is small header size. You can see in the UDP header you have only 4 fields, uh, fixed length header, 8 bytes only. So it reduces the overhead of the protocol. So that's why it gives you fast communication as required by the application. So in the next slide, we see over here that how checksum works. So first of all, we'll see how you can compute checksum at the sending side, and at the destination side, how you can check your UDP segment whether it is properly received or not, whether it doesn't contain any error or not. So at the sending side, what all you have to do to fill up these 16 bits in the checksum field is, first of all, you need to divide your complete UDP segment. Segment means header part and the payload which has come from the application layer, or you can say DNS query, which is a payload in this particular case. So you have to divide the complete UDP header into 16 bit words. Say you can see the example over here. This is a 16 bit word which you can see. So you have to divide the complete UDP segment into 16 bit words, and then you have to add those 16 bit words. Say in this example, if you have two 16 bit words over here, first one is this and second one is this, you have to add these 16 bit words, binary addition. You can see 011 101 110 001. So it's a binary addition. So that is how you need to divide your complete UDP segment into 16 bit words, and then you have to add all of them. If you generate finally at the end, if you generate some query, you need to add this query with the result over here. As you can see, you have the result is this, and the result generates a carry. You have added this carry with this number. So here you can see sum has changed again, and once you have the sum of all the 16 bit words which you have which you got from the UDP segment, then to make that particular sum into checksum, you need to take one's complement of this particular sum or this result. So here you can see sum is this, and after taking one's complement, you can see all ones are 0 in this result and all zeros are ones in this result. So this is the ones complement of this sum, and this one converted ones complement has become your checksum field. You need to put these 16 bits in the checksum field, and your UDP segment is ready to launch, ready to bounce from the client side. Okay, so let me give you a quick recap of this, how you can generate the checksum again. The complete UDP segment which you have, you need to break that complete UDP segment into 16 bit words. As you can see over here, these are the two 16 bit words. The first one is this and the second one is this. In the same way, you will have more. So you need to add all of them. Once you get the result, if your result generates a carry, you need to add that particular carry in this way, and you will again get a 16 bit result, and that result is called sum. You need to take ones complement of this particular sum which you see over here, and once you are done with the ones complement, that ones complement of the result of sum will become the checksum at the client side. And ones complement is nothing, all you need to convert all ones into zeros and all zeros into ones. Here you can see, when adding numbers, carry out from the most significant bit needs to be added to the result. As I told you earlier, if your result generates a carry, you need to add it with the result itself. So that is how you generate the checksum part. Once your DNS query along with the checksum field uh, is ready, and it reaches at the destination. At the destination, again, for checking the bit errors in the UDP segment, you need to again break the complete UDP segment into 16 bit words. This time you have the checksum field as well at the destination side. So you have to break the complete UDP segment into 16 bit words, and you need to add all those 16 bit words if your sum has all ones, means result is all what I mean to say is, if in result all bits are 1, then it means there is no error in the UDP segment which has received at the destination. Or if you do not find all 16 bits as 1 in the checksum at the destination, then it means there is some error. So in simple words, once you add all the 16 bit words of your UDP segment at the destination side and result contain all ones, then there is no error in the UDP segment. But if you find a single zero in that addition, then they mean there is some error in the UDP segment, and at that moment destination has to drop that particular UDP segment, because that UDP segment is not properly received. So that is how checksum works. So that is how UDP provides you fast communication or fast process to process delivery, because you can see in this particular header you have only 4 fields. With the above 2 fields, source port number and destination port number, UDP provides you process to process delivery. And with the length field, it will get you the complete length of the UDP segment, and checksum field is used for checking the bit errors in this particular whole UDP segment. Out of these 4 fields, this particular header has nothing, so it means this UDP segment doesn't provide you um, uh, connection oriented service. It provides you a connection less service, and it is also not responsible for ordered delivery of data, because you do not find anything used for providing the ordered delivery, or at the destination you do not have anything inside this particular header which is used for reassembling the packets in a sequence. So it is not responsible for ordered delivery of data, and it is also not responsible for any type of loss. So UDP is a kind of protocol which is used by those applications which needs fast communication, as we saw in the case of DNS, domain name system. UDP is used because DNS needs fast communication. If um, in case in case DNS loses its query or loses its response, DNS can send that particular query and that particular response again. So main thing is required by DNS is fast communication, and it is also suitable for those applications in which the segment size is small, or it's like message should be small enough to come in a single UDP segment, because there's no provision of reassembling your data at the destination site properly or in a sequential way. So this is the end of our UDP header, and in our next lecture we will see how we are going to how we can create a reliable protocol, because transport layer provides you two types of services. The first one is which we have already discussed in this particular lecture, is uh, for fast communication, which is a connection less and unreliable service, and this service is provided by UDP. And the next service provided by transport layer is connection oriented and reliable service provided by TCP, transmission control protocol. So in the next lecture we'll start designing a reliable protocol, and after uh, one or two lectures we'll discuss TCP protocol in detail. Thank you very much. Have a safe and a nice day. See you in the next lecture.